Great, thank you very much, and thanks very much for inviting me to this conference. What I want to do is actually give some practical examples of a lot of the issues that we've touched upon today through the lens of a special class of big data called consumer data. Consumer data, as defined here, is really data typically big data collected by customer-facing organisations, and we've heard quite a lot about the changing institutional collection of context to data collection, but consumer data account for an increasing real share of the increasing volumes of data that are collected about every one of us in this room as citizens. And so Karima did send some homework to some of the speakers, and here are some of my responses to that through the lens of consumer data as assembled by the centre that I lead at University College London called the Consumer Data Research Centre. So in broad terms, we began this morning talking a lot about definitions of cities and smart cities in particular. From the point of view of consumer data research, I want to think of cities as the locus of human activities at temporal scales ranging really from the diurnal to the dynastic. So we'll actually look at increased spatial granularity of data, a movement towards the individual as the logical geographic unit for front-loading our modelling assumptions that are made about individuals, and measuring and monitoring human characteristics over temporal periods that range from time stamping within a presentation in this conference through to the intergenerational. And in terms of Karima's question about public space and so forth, I mean, I think in a lot of ways, I see cities as the locus of activities. Public space is a land use, it's part of the morphology of land use, but the issues of social equity and fairness that we've begun to touch upon in questioning arising from Manfred's presentation, I think speak more to the way that populations interact and the access that we each have to each other in order to not just generate economic growth, but also to generate the sorts of social and economic externalities about which we've heard quite a lot, particularly, I'll go back in particular to Andres's very thought-provoking presentation this morning. From my own point of view, this is a textbook that I've co-authored through 4 editions and various language versions. And the slide, actually, without going into it in any detail, actually gives one of my concerns, I suppose, really about big data. And that is what the map shows there, if your vision is significantly better than my own, is the 8-kilometre distance between the Calton in central Glasgow and the suburban community of Lenzie, which a UCL academic, Sir Michael Marmot, identified as late as 2011 as having differences in life expectancy between 65 years and 82 years of age. That 8-kilometre distance eclipsing a very significant difference in life expectancy, greater than the median life expectancy difference between India and the United States, for example. And the view of big data, in a lot of ways, doesn't change a lot of geographic analysis. The basic view is these areas are static. It's an inert mosaic where life expectancy differs markedly. And so it's a bit like saying, I wish I knew where I was going to die. Why? Well, I wouldn't go there. it clearly sort of has no resonance, and we don't seem able to move towards an encapsulation of human dynamics that actually moves towards those sorts of models of explanation that several of the speakers have spoken to about. The other one, here's a quote from an opinion polling agency, which also questions the limitations of big data. We seem, actually, despite ever-increasing volume, velocity, variety of data, we seem actually increasingly unable to predict even the outcomes of simple things, seemingly simple things like elections. And the multiplicity of data collection channels and methods seems unable to roll back the tide of uncertainty that handicaps our ability as academics or as policymakers to predict even the sorts of things that we seemed able to predict within reasonable margins of error only a decade or so ago. To pick up something that both Art and Manfred talked about, though, it's very tempting to look back to an age where all data were collected using different sample designs. Every element had a known and pre-specified chance of selection, simple random, stratified random, etc., etc. And the scientific apparatus of inference that Art and Manfred both alluded to enabled us to infer from samples to populations. But that world is a distant memory. I mean, what this slide shows from official government statistics is the 10 percentage or so point decrease in response rates to large-scale public sector surveys. In the world of big data, the velocity, variety of data, how many opinion polls have you declined to take part in since you left your home location to come to this conference? And so even if there was a panacea where we could infer from known samples to known populations, that world has been rolled back, and I think it's a reasonable assumption that it's gone forever. But then, and here, I very much welcome, though, the fight back of scientific orthodoxy that we've heard about from several of the speakers today. This world, though, is equally, it's seductive, but it's illusory. Okay, these are precisely geo-referenced, precisely time-stamped tweets from the subsample of people who use Twitter. I don't. I'm too old, too busy, too involved in other things, that actually also, additionally, are prepared to reveal their geolocation every day, every hour of the day and night. So what is that geography of? Is it a geography of travel behavior? Is it a geography of workplace location? Is it a geography of residence? The only real conclusion that it's possible to draw is that's a geography of narcissism. There's nothing else that it actually represents in the observable world. So, in that context, then, I want to talk about consumer data and the increasing real share of data that are collected about us as individual citizens that is collected by customer-facing organisations. And something else that social science and science should be able to do is surprise. And I think too much of big data analysis, when you question your friends or you ask students or you use tweets and so forth, you sort of know the answer before you start. You get drawn into, data mining is conceived as adit mining. You mine out the seam, the people you can actually get at, but you don't understand the broader landscape from which that seam is mined. True big data analysis should be able to surprise, and I hope I can illustrate the ways that consumer data analysis can surprise. So big data account for an increasing real share of activity. There's lots of things that we could talk about, not only the way that data are collected, the way the behemoths of the internet age, the way they attempt to silo data. We've had some sort of reference to that. The way that big data actually intersects, or rather does not intersect, with the open data movement, whether we're moving to an era where more data are open or more data are closed. That's really another conversation. And this, the Consumer Data Research Centre has its own sort of secure data lab, which is far from open, but does allow access to sensitive personal data, which allow access to big data for the broader social good. Another question that we have to ask about big data and consumer data in particular is, of course, unfortunately, few, if any, customer-facing organisations have a natural, spatial, or economic monopoly. Okay, and so the data that we harvest from customer-facing organisations inevitably provide a partial representation, a partial, and as we've heard, potentially biased representation. And where we can have some control, we can regulate that. So this is an example. This is just south of University College London. The underground station you can see marked in red just near the second red peak on the graphs is the London Underground station of Holborn. The locations A, B and C are three of the nearly 1,000 locations where we've installed footfall sensors that record the Wi-Fi probes of individuals that walk past with Wi-Fi enabled smartphones. And so you can see, this is really an example of the value of open data platforms, because it's possible to reconcile these data with the data that you can see as the peaks on the left and right-hand side of this diagram, which is showing ingress and egress from Holborn Tube Station using Transport for London data. And so this is an example of the potential, when things can go right, of the way that we can link different data sources and think of the smart city as the nexus of flows between locations. Okay, so yes, as I've already alluded, though, I think it's important to customer-facing organisations do not have a monopoly, and their data are not collected for the edification of academics such as myself. The British statistician Tim Harford made the point that big data are exhaust. They're a byproduct of delivery of a customer service, be that a social media service, be it domestic energy, be it transport or whatever. It's a byproduct, it's exhaust, it's not created for our edification, which is really to reiterate the point that both Art and Manfred have made this afternoon. But our researchers, and we have a team of about a dozen or so people working at UCL and others at the Said Business School and the University of Liverpool, work on these things to clean them up. And so the left-hand diagram there are some store loyalty card data from a high street retailer. The right-hand side are the data cleaned up. Basically, the address information's rubbish. But if you look at the locus of the activities of the retail stores that are patronised, you can clean up the data. Great for the retailer, great for the academic, because we can redefine, with the geographic and temporal precision, we can look at activity patterns of individuals in terms of probable workplace, leisure destinations, airport destinations, and so on and so forth. And this is much the same. This is Anastasia Oshakova's work using smart meter data from one of the UK's big six energy providers. We have smart meter data assembled for energy consumption for every 5 minutes. And basically cleaned up. These data can give us purchase on broad issues of smart cities, the Energiewende, sort of that is taking place in all societies in differing ways, so that we can identify consumers that can adjust consumption, use electric cars along with domestic energy in harmony, etc., etc. And it's a broad example then of consumer data, which really, as I say, allows us at higher levels of spatial and temporal precision to realise the Hagerstrand time-space prism at greater levels of granularity, very often at the level of the human individual or the individual household, and with very precise time stamping. And the time, the dial of the clock there is deliberately not calibrated, because it can say that in seconds, minutes, hours, or generations. So I said a few moments ago, big data can surprise, and I think this is a good example of how big data can surprise. What we see here is the index of multiple deprivation as measured by UK government. I think it's about 16 bars, okay? And so these are the most deprived part of the population. These are the most affluent, okay, in very crude terms. And you can see in terms of the frequency, the highest frequency is about 100 individuals. And this is a subpopulation. These are all the adult bearers of this characteristic, okay? And you can see that the distributions are very different. I mean, I haven't calculated a Getty statistic or anything like that, but I think we would agree these distributions are very different. And that characteristic can actually only be ascertained using consumer data. And we could play a silly game where I'd say, what is the characteristic, this, that, and the other? I'll tell you. The characteristic is the name you were born with, okay? And so if your surname is Walcott, you're very poor. If your surname is Offer, you're very rich. And that is absolutely astonishing, because those names were bequeathed on the first generation of bearers of those names sometime between the 12th and the 14th century, okay? And it relates to actually one of Andres's colleagues, Neil Cummins, who work at the London School of Economics, which actually really sort of poses, there's only two resolutions of that paradox. It's either nature or nurture, okay? And the social historian perspective is that wealth is a more directly inherited trait in an intergenerational sense than height. And that's Neil Cummins' conclusion based on analysis of the Oxford and Cambridge entrance rolls of rare surnames over the medieval period. Okay. The other hypothesis: social historians don't do space, and so the other hypothesis is that the economic opportunities offered to generations of Offers and generations of Walcotts are profoundly different. And we can do it with, that is a contrived example, but using different big data harvested from a range of sources, we can do it not just for Britain, but we can do it anywhere in the world. Okay? And so I know how far from home you are. So we can look at the geographies of bearers of names from contemporary periods of very high levels of precision. In the Consumer Data Research Centre, we've harvested nearly 2 billion individual names. Okay, and that is quite a good sample of the planet's population. It's from every country, differing sampling fractions depending on what we can get our hands on, but it does allow robust inference as a big data source. It also speaks to the agenda of this meeting about sort of smart cities and human and social capital formation. So, two names from fairly recent British history, very different. Political views, very different historic origins. This is not quite big data analysis. This is the individual records from the 1881 census of population of the geography of bearers of the name Thatcher and Blair. Very different, and you can see a very skewed Gini coefficient. We can relate that to the geography of those names today. And so we can look at, just taking the right-hand side of them, we can look at the way that the geography is actually spread from the heartlands of 3 or 4 generations ago to today. And so this this allows us a view of the smart city, which is actually quite new and exciting, because if any of you know the geographer Michael Palin from his TV shows, this is something we actually did for him. But if you look at the way that a name spreads across time, you can see the classic processes of contagious diffusion and hierarchical diffusion. Okay? And so the Nijkamps that are here in Den Bosch, they've come here for a reason. Okay? And so a place with names which do not historically originate in that area is probably more dynamic than one where the name distribution has not changed over time. And so this is, I think, a big data, a new perspective on the human and social capital that it's ingrained in places, just harvested by looking at a simple characteristic. Margaret Thatcher and Tony Blair, the names also betray other characteristics. This is the age distribution of people called Tony, and most people called Margaret, close to popping their clogs, as is our former, as did our former Prime Minister. And so these sorts of geographic and demographic characteristics harvested from something as simple as names information can allow us to draw the sorts of inferences that Art and Manfred were worrying us about. So each of these graphs has the demographic age profile of Greater London superimposed here for reference points. And here are geo-reference tweets at 4 London locales, including the Manfred Fisher Stadium of Enlightenment, otherwise known as Arsenal's Emirates Stadium. And so here, from the geo-reference tweets, we know the location. From the Twitter handle, we infer the name, and we infer the age. And so you can say something about the characteristics, the level of bias that's associated with the people that are in that place and how different they are from the nighttime population. By linking these individuals across time, we can also say something about geographic mobility. So here are quintiles of the UK housing market in terms of value, and most people move from the bottom quintile to the bottom quintile. There are different reasons for social mobility being associated with spatial mobility. The left-hand diagram here shows the geography of the Bangladeshi population from the 2011 census. Okay? And a name is also a statement of ethnicity. And so, based on the analysis of names, this is the geography of people who have Bangladeshi names in 2011 from the Consumer Register. And they're pretty similar. Then this one's different. But this one is the census category white other. Okay? If you want to know the geography of first or subsequent generation Greeks in Britain, that's as far as the census takes you. They're white other, as are Poles, Romanians, French, etc. This is the geography of people with Greek names. And so it allows us greater granularity without sacrificing the power of inference. Something relevant to Andrus's presentation this morning, I think, and Kolkata. This is another of my little graphs showing the frequencies, this time the 2 Indian names, okay? And you can see of names imported from abroad, the Banerjees have fared a lot better in British society than the ACTHARs. And so we can using big data, we can go and look at the geographic distribution of each of them across sort of each of the very low-level areas in geographies in India. And so the ACTHARs fairly evenly distributed. And if you look at the global map, which I haven't got time to show you, they've all the ACTHAR diaspora is basically India and Great Britain. The Banerjee one's different. A lot of doctors, bearers of those names in the Middle East. And so here we see not only a different distribution in terms of origin-destination flows, but we see a different global diaspora overall. And when we look at the actual heartlands, where they came from, going back to Andrew's talk this morning, he was saying Calcutta isn't that dynamic. Well, a lot of people have obviously moved out of that area as bearers of those names. And so in terms of smart cities, what this allows us to do is build up highly disaggregate pictures using big data of the composition of different areas. And my hypothesis here, you can look at the composition of any area saying, okay, sort of over the last 1, 2, 3, 4, 20 years or 150 years, how many people have moved there? And if they've moved there for a reason, which is to speak to the dynamism of the area and move beyond just the very useful density analysis that we heard about this morning. I'm running out of time, but there's lots of other things that we do really at the Consumer Data Research Centre. We look at the delineation and functioning of rural areas. We look at, there was some discussion this morning about health. We look at access to health and consumer-based healthy behaviours using lots of different indicators. We look at the geography, the very variegated geography of online behaviour and the different forms and habitual patterns that relates. And in all of this, we try to triangulate the data with conventional sources and to maintain the sorts of links that Art and Manfred were describing. And so here, for example, I think this should animate. This is just showing population churn over the period 1998 to 2017. We took delivery of the latest 2018 data 2 days ago, and so this is data which are created and updated in something approaching real time. And here for the city of Bristol, you can see what you really expect. You expect sort of basically the core of the area, the mobile student population, to have a much higher population churn. This area is interesting. Look at the way this suddenly jumps. And again, in terms of triangulation, in terms of this, here's some satellite imagery showing why that jumps, because basically the start of the time period, it was a greenfield site, and now it's a massive housing estate. And so here again, basically in terms of census of population, the UK Census of Population has 12 population groups. We have 180 cultural, ethnic and linguistic groups using our names classification. And so again, you can look at London's changing geography in terms at highly granular scales, both spatially, temporally, and in this case, ethnically. Thanks
Thank you very much, Paul. And I really feel bad about having to say stop, because in fact this is really exciting stuff, and I would love to to learn a lot more and look at these interfaces, because they're very interesting the way you do. Before they're going to ask people to comment, I actually have a comment about the names analysis, just because, and Bart will know this, in New Zealand this is highly controversial, because there is an issue that housing markets have been, the housing market in Auckland has shot up, that houses are unaffordable, price of a house relative to is 10 times the average income of a household. And the argument, so somebody has to be blamed. And because we don't know the background of buyers of property, the only thing that's known, officially publicly known, is the names of the people who are on the purchase contract. And so what did they find out? That a lot of these contracts had Chinese names on them, or Asian names. And you can imagine the political controversy that emerged to start with. What do these names mean? And also, in fact, if they were Chinese, some of them had lived in New Zealand for 100 years, and they're not like foreign investors coming in. So I just wanted to point out that there is this names analysis is not without controversy, and about criticism about the limitations.
Yeah, so there are different ways of doing that. So in the UK, for example, people have mapped the geographies of properties that are owned by companies. In Britain, property ownership is such that overseas investors tend to buy properties through companies, and so it's not just names. There's lots of consumer data sources you can use to identify that.
Okay, thank you. We'll have some more. Let's just a couple of questions before we have afternoon tea. I think we should allow for that. Yeah.
How did you choose names like Wallace? And did you have preconceived notions, or you knew something?
Yes, of
that
course.
would show this contrast?
No. I mean, the best Gettys tradition. Sort of, I knew what I was looking for the slide. So yes, it's perfectly possible to comb through thousands of names, which is the big data analysis part of it, to get the outcome sort of that you want. But the same sort of principles hold for a very surprising number of names that have geographic concentrations in parts of the country that have fared better or worse over time. Yeah.
Peter?
Thank you, Paul. I learned a little bit more about my own history. Can you just show the picture with my name on it, and I'll try to interpret that picture.
You'll be the first person to interpret it. I mean, basically, it is data blind in that sense. Yeah.
There we go. Well, it looks like some sort of a past dependency, and it is certainly a past dependency, but you have to know, if you do this analysis of names, first, names were given in most of Europe only during the Napoleonic time. Then people were forced to have a family name. Before, it didn't matter at all. So it means somewhere in the beginning of the 19th century, someone picked up the name Nijkamp, right? And that person was by coincidence living in that area. Now by then, if you found another partner, the action radius to finding another partner was very limited in the eastern part of the country. It was completely isolated. Why was it isolated? It's not clear on the map, but give me your pointer, yeah? And that explains, I think, the whole story. You have to know that the Netherlands, we are somewhere here now, the Netherlands has, if you cross from Amsterdam to 's-Hertogenbosch, you cross 4 rivers. That was a natural barrier. Everyone living up north never went to the south because you had to cross 4 rivers, no bridges, nothing at all. In this particular part, so let's say there was one person picking up the name Nijkamp. You are free to choose any name, by the way. There's another river going here, from the River Rhine up to the lake up there. So there's a natural barrier on that side. There's another natural barrier on this side. These were swamps in the past, so that was completely inaccessible. And here's the German border. So by the fate of history, the Nijkamp family was completely locked in that part of the country. It never managed to get out. I'm the only one living out of there. Right? Okay. So there is, if you look into these patterns, it's interesting to see these patterns, really fantastic. But the causal explanation why it happens could be networks and could be all kinds of liaison strategies, etc. What is more important that sometimes not only family names are geographically related, they have also various similar psychological traits. All people with my first name in this part of the country have the same characteristics in terms of mental attitudes, etc. They're all identical. Every Peter in that part, I can predict how he is. And there's another theory about it. But okay, that's a different story.
Okay,
well, I think that is a wonderful...
No, I think that is actually an interesting... again, this is big data as hypothesis generation. One of our researchers is looking at digitized street networks, and you look at the evolution of road networks over time in association with the evolution of patterns of names. Yeah.
Okay, well, I think we need to wrap it up here because it is afternoon tea time, and I think there's been a wonderful session, both with very broad theoretical perspectives and challenges, and also some really very, very interesting data analysis of kind of an unusual nature. So, Paul, thank you, and also thanks again to the other two speakers and everyone for participating this afternoon. Thank you.